Welcome back to the channel. We've got another question from the mailbag, and I'm glad this one came in. It's about a basic roof as you can get, and it's going to be the building block to do further learning about how roofs are cut, how they're calculated, and how they're put together. So this is just straight up how to find a rafter length on a super simple roof. First thing we need to do is find out the slope of the roof. Now to do that, we need two pieces of information. We need the rise of the roof and a run value. So the rise, written right at the top of the page here, top of wall to top of ridge, is 1 foot. So we've got a 1 foot, 12-inch value of rise. Now run is a real simple calculation. It is simply span, which is the overall size of the roof, divided by 2. So 8 feet divided by 2 is 4 feet or 48 inches. That was real simple to find our rise and run. Now those are total values, and we usually work off of our slope triangles, which is a value over 12. So we need to reduce our total values down to what our slope triangle is. And that, on this roof, again, super straightforward. We just take 48. How many times can 12 go into 48? 4 times. So we have to divide our other value by 4 as well, which gives us 3. Simple ratio and proportion. We're dealing with a 312 slope roof. From there, we can simply grab our framing square and start reading the tables right here. Common rafter length per foot run. Now our per foot run is this triangle right here. We need to find the 3 values, so we go down the top of the square to where the 3 is, and we can read our value right off the square, 12.37. So the slope value is 12.37 inches per foot of run. Now we have 48 inches, which is a 4 feet of run. So we multiply our slope value there by 4. 12 goes into 48 4 times. So 12.37 times 4 units of run equals 49.48 inches. Let's put that into fractions. That's 49.5. So 49.5 inches is from the end of our wall to the center of our ridge. Now we've got a 2x6 ridge board going in there, so we do need to do an adjustment for the actual thickness of the ridge. This 49.5 is what's called the theory length. It's going to be an imaginary value between the corner of the building and the absolute center of the building. Since our material takes up space, we need to account for that. Now, being a 2x6 ridge, it's going to be 1.5 inch thickness. So when we lay out our rafter at the top of the ridge, we'll have our slope or our plumb cut marked out, and then we will need to take that and reduce it by half the thickness of the ridge. So I'm just going to move that over and measure perpendicular to that line. Actually do it with the tape measure so you can see a little better. Measure perpendicular to this line, half my thickness back, so 3/4 of an inch, and then remark that for the cut. So this is our theory line length, and this is our cut. That's half the thickness of the ridge taken off to accommodate the ridge board going in there. Now since this has no overhang, on the other side there won't be any adjustments because it's going to just end flush with the building. All that will need to happen is where the plumb cut is at the seat. There's our plumb cut. We'll just need to go our wall thickness, which I'm assuming is 3.5 inches, and put a seat cut. So that will get cut out, that will get cut, and we will have a seat for the wall and in line with the end of the building. Now there's one other way you can find that 49.5 value, and it's just using Pythagorean theorem, because this is a right angle triangle. We can use our overall run and our overall rise to find our overall theory line length. All we need to do is go 48 squared plus 12 squared equals, get the square root of that. Whoops. Gives us 49.48. So that is the same number that we got originally, it's equal to 49.5, and there is the value of your rafter length. So I hope this helps. If you have any questions, feel free to drop them in the comments below, or hit me up on Instagram at Byron Builds, or hammer.com/Byron Builds, and together let's build back trades, abolish trade secrets, and I'll see you on the next one.